Welcome all the students. Today we are going to discuss the topic, that is, I think we have already started learning the point filling area primitives. Okay, and in the last session we have learned what is meant by the scanline polygon fill algorithm or different scanline polygon filling algorithm. Today we are going to learn the point inside outside test. Okay, so today's topic of discussion is inside outside test, and in the after that next session we are going to learn about boundary fill and flood fill algorithm. Okay, so today's discussion, very interesting point, that how we can find or how we can detect inside and out, can carry out the inside outside test. Okay, for the polygon. So, as I have said, the topic of discussion is inside outside tests. Okay, now you can find that the area filling algorithms and other graphic processes, okay, often need to identify, what we have to identify is whether the region is interior or whether it is exterior, or whether the given region of the polygon is interior or whether it is exterior, means whether it is inside or whether it is outside. Okay, because accordingly what we have to do, we have to fill this with the color. Okay, if it is interior or it is inside, we are going to fill it with the color. If it is outside, okay, then we are not going to fill it with the color. Okay, interior means if it is inside, okay, exterior means if it is outside, okay, and accordingly we are going to fill this with the color. Now in elementary geometry, we can say the polygon is usually defined as having no self intersection. It is not having no self intersection. So we are generally calling these are the standard polygons. Okay. So I say the standard polygons are not having, I think I have written here, they are not having no self intersection points. Okay. So no self intersection points are there. Then we can call these are the standard polygons. And the example is triangle, okay, then rectangle, octagons, okay, decagons, or all these that we are considering as the different types of the polygon. Okay, so now as we are considering these are the different types of polygon, okay, identify the interior region of the above standard polygon is generally a very straightforward process. Okay, so if my polygon is a standard polygon, okay, if my polygon is standard polygon, it may be triangle, rectangle, square, okay, and all these are the different types. Okay, then what we are going to do, or I say that the identifying or to find out the interior region or identify whether the region is inside, okay, is a very straightforward process or whether it is very easy process. Okay, and accordingly we can fill this polygon. Okay, but now we are considering the special case here. Okay, so I'm moving to the next slide. Now what we are going to do is, okay, now I think before I move to the complicated polygon, okay, so this is not the case with complicated polygon. So before I move to the complicated polygons, I think we just learn one more important term related to this, which is called as bounding box. Okay, now what is the term that we are going to discuss is what is mean by, because before we go to the complicated polygon, we must understand what is mean by the bounding box. Okay, now the amount of work, means the filling work, the amount of polygon filling work, the amount of work is reduced. Okay, the amount of work is reduced by computing the bounding box for the polygon. So we have to find out the, or we have to compute the bounding box for the polygon. Okay, now what is bounding box? Bounding box is a smallest rectangle. The bounding box is a smallest rectangle that contains the polygon. Okay, smallest rectangle that contains the polygon is nothing but we are calling it as a bounding box. Okay, now if I plot the bounding box or whenever I find out the bounding box, therefore only those points inside the bounding box are examined or they are considered at the time of filling. Okay, so what we are going to do is first we have to find out the bounding box of that polygon to reduce the amount of work. Okay, and now this is what is shown in the diagram. Okay, so this shows the polygon bounding box. Okay, now if you have to look at the diagram number A, okay, just look at the diagram number A. This is my polygon. Okay, so this is my actual polygon, and this particular, okay, so I think we have shown this with the dotted lines. Okay, so this is my bounding box. So I consider the bounding box is the smallest rectangle. I'm having the smallest rectangle. As you can find that we have written here, it is a bounding box. Okay, so it is the smallest rectangle which is going to cover the entire polygon. Okay, now what is going to happen due to this? I think I will just consider all the pixels which are inside the bounding box. I think there is no need to consider all these pixels. Okay, this one, this pixel, these areas are not considered, or there is no need for me to examine. There is no need for me to consider all these areas. I will consider every pixel, or I will consider, or I will examine every pixel which is inside the bounding box. Okay, so that is what the advantage that we are having the use of bounding box. Okay, the second example is also shown here. Okay, in the diagram number B, you can sign this is my polygon, and now for this polygon, I think this is what the rectangle that we are having, okay, which is going to give me the bounding box. Okay, so this is my bounding box and this is my polygon. Okay, so generally this bounding box is also having the x and y minimum value. Okay, so now if I consider this is my bounding box, you know that this will be my x value, okay, which is I call it as minimum. Okay, I use this word as x is minimum in this case. Okay, so I just use x minimum. Similarly, I consider this particular point here. You can know that this is the x which having the maximum value. Okay, so x is maximum here. Okay, I consider x max. Okay, x is maximum, x is minimum. Similarly, I can say that this is the point where the y value is minimum. Okay, here it is y value is minimum, and here is the y value of the bounding box which is maximum. Okay, so this is y max. Okay, getting me? And this is the point I consider here y is minimum. Okay, now why we should get this y max, y minimum, or x minimum, x maximum values? Because using this I can draw this rectangle. Okay, now if I want to draw the rectangle, I have to give this 4 points. Okay, generally I will draw the rectangle. I think if I use the rectangle function in my C program, then I'm having the value rectangle. I have to give the left side top. Okay, left top value I have to give this point to draw the rectangle. So the value will be x minimum comma y maximum. Okay, if I consider this is my 0. Okay, and then I have to give the second point that I have to give to draw the rectangle is x maximum comma y minimum. Okay, so if I give this value, okay, it is going to draw this particular rectangle that we are going to call it as a bounding box. Okay, so what we have to do before we apply any polygon filling algorithm, okay, before I'm going to apply the polygon filling algorithm, what I have to do is I have to go for bounding box. I have to compute, I have to find out the bounding box, so my amount of work is reduced. If I'm not doing this, I think my if I though I consider scan line also, or I consider anything, I need to reach up to the end unnecessarily. I may start from this particular point. I think all these areas are unnecessary. Okay, there is no need to consider all the pixels on this particular scan line or these areas. So that's why we have written the amount of work is reduced by computing the bounding box. Okay, and I can have to find out which is the x minimum, x maximum, y maximum values of my bounding box. So all the pixel I'm going to examine, I'm going to check with for x, it will be in between x minimum to x maximum, and it is having the range will be y minimum to y maximum value. Okay, so that is what we have considered. Okay, I hope so all of you easily understood what is bounding box test or what is bounding box. Now we will continue our discussion. Okay, what we have started discussing is for a standard polygon, finding out whether it is interior, okay, which region is inside, which is outside, is easy task, or it is a straightforward task. Okay, but for complicated polygons it is not easy. Okay, so that's why to explain it I'm just moving to the next slide. So again, I continued with my inside outside test. This is the point that we are going to discussing. We have started discussing. Okay. Now what I have written, the most graphics application we can specify any sequence of vertices. Okay, we can sequence any number of vertices of a field area, including sequences that produce intersecting edges. Okay, that is going to produce the intersecting edges. Means inside the polygon, the edges are intersecting with each other. So I call these are not standard polygons. These are the complicated polygons or complex. That's why I say complex polygons. Okay, as shown below. Just look at this diagram. Okay, I want everyone to look at the diagram. See here, which are type of polygon? These are self-intersecting polygons. These polygons are self-intersecting. You can find that this is my A point. So from A, I'm moving to B, B to C, C to D. Okay, I can just show for your example. Okay, my first edge is I'm moving from A to B, then I move from B to C, I'm moving from C to D, then I'm moving from D to E, E to F, getting me? F to G. I think though we have not written, this is the G point. I think here it is written in the diagram. So this is G, G to A. Okay, now here what is happening, why I have considered this as a special case, because these are the polygons which are intersecting with each other, self-intersecting. You can find that the edge A and B intersecting to edge C and D, as well as it is intersect with the edge F and G. I think we are having the G here, getting me? As well as it is intersecting the edge F and E, getting me? So all these are considered as not standard polygons, but they are considered as complex polygon or self-intersecting polygon. Getting me? These are the self-intersecting polygons. Okay. Now for such shapes, for such self-intersecting polygon, it is not always clear that which region of xy plane we should call interior and which we should call exterior of the object. So from this, I think it is difficult for us to understand which area is interior, okay, or inside, and which area is exterior, that is outside the object or outside the polygon. Getting me? So we have to find out from this such polygons which is inside means which is interior and which is outside means which is exterior. Okay, that is what we have to find out. Okay, now now is there any method for it? Yes, we are having two methods for it. Graphics packages uses following two methods. So there are the two methods to identify the interior regions of object. Okay, so which are these two methods? The first method is we are using one method called as odd even rule. So there are the two methods to identify interior region of the object. The first one is known as odd even rule. So first method of inside outside test. First method comes under inside outside test is odd even rule, and the second method that is used is known as non-zero winding number rule. Okay, non-zero winding number rule. So this is my first method. Okay, and this is my second method of inside outside test. Okay, and generally it is applicable for complex polygons or it is applicable for self-intersecting polygons. Okay, so this is now we are going to learn these two methods in detail: odd even rule method and non-zero winding number rule method. Okay, so I continue with the discussion. I'm moving to the next slide. Okay, so what is the first method that we are going to learn? That we are going to learn is odd even rule method. Okay, so I just read the description and then we will going to see the example. It is also called as odd parity rule. In some of the textbook, it is instead of odd even rule, it is also known as odd parity rule. Or in some of the book, it is also referred as even odd rule. Okay, odd parity rule or even odd rule, even odd rule. By conceptually drawing, what we have to do by conceptually drawing a line from any position P. So I have to draw a line from any position P to a distance point outside the coordinates extents of object. Means from internal any position P which is inside, from that I have to draw the line which is goes to the outside of the polygon. Okay, which goes outside to the polygon. Then counting the number of edges crossing along the line. What I have to do after drawing this line, after drawing a line from the point P, which is inside, to the distance point outside the coordinate exchange of the object, means outside the object. Okay, after that what I have to do, I have to count, okay, count the number of edges crossing along the line. Okay, we have to find out number of edges it is going to cross, number of edges it is crossing along the line. If number of edges crossed by this line is odd, see what I'm saying, the number of edges crossed by this line, and if I get that number is odd value means if I get the number is 1, 3, 5, okay, then what indicate the P is an interior point, or the P is inside. Okay, it is an inside region, then P is inside. Okay, otherwise, okay, otherwise that is if number of edges crossed by this line is even, number of edges crossed by this line is even, means it is 2, 4, etc., then the P is exterior point, the P is outside the polygon. Okay, so it is exterior point, and obviously that is not filled with the color, that is filled with the background color. Okay, so this is my odd even rule. Okay, now I think to understand this we should consider the diagram, and then we are considering this in detail. Okay, so example of the same is shown in the diagram. So I think I want everyone to look at the diagram so you can understand. Okay, now here I think in the diagram number A we have using odd even rule. Okay, so I'm having this polygon, I'm calling this polygon as self-intersecting polygon. It is not a standard polygon, or we can say it is a complex polygon. Okay, now what is my rule? Okay, how I have identified. Now here you can find the area which is filled with this blue color. Okay, indicate the area is interior. Okay, everything it is inside. Okay, this is interior, and this particular part which is shown with the white color, I think this and this part is exterior, means it is outside the polygon, or it is outside the object. Now you can say that how I have find it out it, how to find out this whether it is interior or exterior. So we apply the rule. Okay, so what is this rule says? Drawing a line from any position P to a distance point outside the coordinate system. Okay, now suppose I want to find out this region. Okay, so I want to find out this region, so I take this is my point P. Okay, see, I'm just giving you the example. This is my point P, and I have to draw the line from this P to the outside. So outside means suppose I have drawn it over here. Okay, so this is my line, point P to line, which is outside. Okay, now what I have to find out this, I have to find out, count the number of edge crossing along the line. So this P line, okay, crossing along, how many edges it is crossing? It is going to cross the one edge. This is my first edge which is going to intersect, it is going to cross. Okay, after that whether it is crossing any edge, no. So number of edges it is going to cross. See, if the number of edges crossed by this line is odd, because only one edge it is going to cross, then the P is interior position. So I come to that, this complete area of the P is interior. Okay, I hope so all of you got it. Suppose this is my P and I have drawn this line. Okay, this is my P, this particular area P, I have drawn line. It is intersecting only one edge. One means it is odd. Okay, how many edges it is crossing? If it is one, yes, here it is one, so this is interior. Okay, I take for this line. Okay, suppose this is my, I want to find out this area or the point whether inside or not. Okay, I will just go for this. Okay, this one, from here I have drawn it. It is intersecting how many edges? Only one edge. One edge means odd means it is interior. Getting me? Now you can ask, I can draw this pixel, I can draw this line. Okay, suppose I have drawn this particular line. See what I am saying? I want everyone to just look at this. Suppose this is my point. Not necessarily I will draw at this side, I will draw at any side. Getting me? Suppose I have drawn this particular point and line which is out at this side. Okay, this is my line now. Okay, consider this is the line. From this it is the line. Okay, now what about this point, whether this point is inside and outside? How many edges it is crossing? This is the first edge, this is the second edge, this is the third edge. So it is crossing three edges. Okay, if three means odd means this is inside. All of you, I hope all of you clear with this. Now what is whether I am having any area which is exterior? When it is exterior, when the number of edges it is crossed is even, then it is exterior. Okay, I just take this as an example. Suppose this is my point P. Getting me? This is the point P, and now I will draw the line like this. Okay, this is a line. Okay, what is going to happen? It is going to cross. This is my first edge. It is crossed. It is going to cross the second edge. This is the first edge. This is the second edge. Okay, first edge and this is the second edge. Okay, now how many value number of edges cross? It will be 2. 2 means it is even. If it is even, the P is exterior point. So this indicates that this particular area is exterior. Okay, I may draw any line. Okay, for example, suppose now I talk about from this, I draw the line over here from this point to this. So how many it is crossing? 1 and 2. 2 means it is even. If it is even, it indicates that it is exterior point. Okay, number of edges cross is even, the P is exterior point. Getting me? Now we talk about this particular area. Getting me? This area. Suppose I consider this is my point and I take this is the line itself. This is my line. Okay, it is crossing how many edges? 1 and 2. 2 edges means it is even. So it is exterior. Or you may draw the line from here to here. Okay, so how many edges it is crossing? This is 1, this is 2. This is 2 means again it is even, so it is exterior. So this particular area is also exterior. You may take the line from here to this side. Okay, maybe this to this. Again it is crossing 2 edges. This is first edge, this is the second edge. 2 edges means it is even, and if it is even, it indicates that it is exterior point. Okay, so as per our rule, we applied for odd even rule. Okay, take any point from inside and go to the outside. Okay, so what is going to happen? I will count the number of edges it is crossing. If it is going to cross the number of edges and that value is odd, the P is inside, and if it is even, the P is outside. Okay, so that is the simple test that we are doing to find out the region, whether it is inside, whether the region is outside, and we are applying this for the self-intersecting polygons or complicated edges. Okay, I hope so all of you cleared with how we will apply, how we have applied odd even rule. Okay, so this is what our discussion that we are having. Okay, so you can take any region, no issue. Okay, for example, suppose I have take this region as suppose this one. Okay, I take this region, so I draw the line from that region to outside. Okay, from this region to outside, how many edges it is crossing? It is crossing only one edge. So 1 means odd, odd means it is inside. If I take the region this region, I take the line something like this. From the line points, starting of the point of the line is inside and it will go outside the region. Okay, how many edges it is crossing? Only 1. 1 means odd, so that's why this is inside. That's why this region is interior. Okay, so interior region is filled with the blue color and exterior region is white, that is background color. Okay, so this is what the simple test that we are applying, which is called as odd even rule. Okay, used for inside outside test. Okay, I think we are having one more method for the discussion, so I just move to the next slide to discuss that method. Okay, so just discuss one more method of inside outside test. Okay, I just move to the next slide. Now what is the second method we are having? What is the second method? The second method name is non-zero winding number rule. Okay, so we have seen one method which is odd even rule. Now we are learning second method of inside outside test, which is known as non-zero winding number rule. Non-zero winding number rule. Okay, now what this does, this method counts the number of times the polygon edges wind around a particular point in the counterclockwise direction. So we have to consider the polygon edges first in the counterclockwise direction, not clockwise direction or anti-clockwise direction. Okay, now the count is called, okay, whatever the count that I'm having, count the number of times the polygon edges wind. Okay, the count is called the winding number. The count is called as the winding number. That's why the name is given as winding number rule. Okay, and the interior points of the 2D object are defined to be those that have a non-zero value. Okay, so after this, we have to find out whether it is having the non-zero value, whether this winding number, this count is called as winding number, whether it is a non-zero value for the winding number, then accordingly we decide. Okay, so what is the next point? Or this is nothing but these are the steps, we can say, of the non-zero winding rule. We apply the non-zero winding number rule to polygon by initializing the winding number to 0. What is the initial value of winding number? Is the initial value of winding number is 0. Okay, so initial value is 0. And again, imagining the line drawn from the point P to the distance point beyond the coordinate extents of the object. This is same as we have done in the odd even rule. Okay, draw a line which is starting from the point P. P is inside, and draw the line which is moving to the outside of the polygon. Okay, no issue. Now here, what we have to do, here we have to take one care. The line we choose for the non-zero winding rule, the line we choose must not pass through any vertices. It should not cross the exact vertices or exact point of the vertex of the polygon. Okay, so that is what the care that we have to do. Okay, the line we choose should not pass through the any vertices. For example, suppose I am considering this is my triangle that I'm having, getting me? Okay, suppose this is my triangle, and now it is having this vertices point. This is the point, this is the another vertex point, this is the another vertex point. Okay, suppose this is my point P. What I have to do, I should show P is passing from this. This is correct. Okay, but if I show that the P is passing from this, okay, it is passing from the vertex, then this is not allowed. Okay, it should not, we choose the line, the line we choose must not pass through the vertices. Okay, so if it is passing over here, it is correct. It is passing over here, it is correct. It is passing from this side, it is correct. But suppose this point is passing from exactly the vertex here, from this particular point. Okay, this is my vertex. Okay, then it is not allowed. Okay, so the line we choose must not pass through any vertices. Okay, so let us understand this. Okay, so I'm having, with the help of the diagram, that how this non-zero winding number rule works. Okay, with the help of the diagram. Okay, so I'm just moving to the next slide for the discussion. Now, as we move along the line P, okay, to the distance point, we count the number of edges that crosses the line in each direction. Okay, so here we are having we already have drawn the polygon edges with the counter or anti-clockwise direction we have considered. Okay, so in the non-zero winding rule number, we continue in the discussion. As we move along the line from P to the distance point, we count the number of edges that cross the line in each direction. Okay, and then what we have to do, we add 1. Okay, what we have to do, we have to add 1 to the winding number. Add 1. Okay, this is 1. Okay, add 1 to the winding number every time we intersect a polygon edge that crosses the line from right to left. Okay, so if I'm moving, if I'm having the intersecting of the polygon edge that crosses the line from right to left, we have to add 1. Okay, add 1 value, and we have to subtract 1 value. Okay, subtract 1 value every time, subtract 1 every time we intersect a polygon edge crosses from left to right. Okay, crosses from left to right, what we have to do, we have to subtract the 1. Okay, we have to add 1 and we have to subtract 1. Okay, now see, this is what the diagram we are having. Okay, I want everyone to concentrate, then and then only you will understand how exactly this non-zero winding rule works. Okay, this is non-zero winding rule number works. First, what is my step number 1? In my step number 1, I have to start from A, and I have to mention this arrow, and I'm moving from anti-clockwise direction. Okay, not I'm moving from the clockwise direction. Okay, so this is my first arrow, A to B. This is my arrow. Okay, then after B I'm moving to the C, arrow position will be changed. This is my, from B to C, this is the arrow. D to E, again the arrow position is changed. E to F, I'm moving in this direction. F to G, I'm moving in this direction. G to A, I'm moving in this direction. Okay, So first of all, you have to mark this directions accordingly. Okay, we have to mark all these directions starting from in anti-clockwise direction, not from clockwise. If I move from A to G, it will be clockwise. I'm moving from A to B means it is anti-clockwise. Okay, I'm moving from this direction. Okay, I'm not moving from, so if this is 12, okay, then I move from 12 to 11, 10, 9 as per the anti-clockwise. Okay, now what we have to do now, as we move along the line, first draw the line. Okay, so suppose I am going to draw the line. See, I'm drawing the line. In this case, suppose this is my point P. I want to find out the point P, whether it is inside or outside. What I'm going to do, I will draw the line similar to this. So this is my line which is moving from this to this. Okay, so what we have to do, we add 1 to the winding number every time we intersect the polygon edge, crosses the line from right to left. Okay, so we are just moving from the any direction, it not matter. Okay, so here I am having it is which direction, I assume one direction. So direction 1 means 1 will be added. So my answer is 1. Okay, now if it is 1, what will be interior or exterior? Okay, that is what I have written. The final value of the winding number after all edges crossing have been counted. For this particular point, this particular line, there is only one crossing edge, that is 1. Okay, the final value of the winding number after all edge crossing have been counted if the winding number is non-zero. Okay, if the winding number is non-zero, here it is number is 1. Okay, it is crossing 1, it is added 1, 1 is added. So for this particular line, the winding number is 1. Okay, so if P is defined to be interior, if it is non-zero, yes, it is non-zero. P is defined to be interior region. So I can find this is inside the polygon filled with the color. Otherwise, okay, otherwise, that is if the winding number is 0. Okay, if the winding number is 0, then what it says, it indicates that the P is exterior point. If winding number is 0, the P is exterior point. Okay, so now what is, how we are going to assume, how we are going to consider this. Okay, suppose I consider this is my point. Okay, I take this as a point. Okay, and then one thing, it should not crosses to the edges. Suppose I have taken this into this, this is the point, it is crossing only one edge. This is the one edge, adding 1, add 1 means this answer is 1. Okay, I talk about any other point. Okay, suppose this point. Okay, now I take this as a point and this is my line. Okay, so this is my line. Okay, now here what about this, here they have written already it is exterior. Why it is exterior? So my question is, my first edge is, I think, moving in this direction. Okay, so I add 1. So 1 is added. So what is the counting winding number? It is 1. Second edge it is crossing. See, it is crossing the second edge. Second edge, what is the direction? What is the direction of second edge? It is reverse of first one. So 1 is added, 1 is subtracted. Okay, here 1 is added, here 1 is subtracted. This direction is different and this direction is totally different. These two directions are opposite of each other. So here it is added, it is subtracted. Okay, so what is my answer? My answer is 0. My winding number is 0. So that's why this particular region is exterior. So this particular region is exterior. Getting me? You can take any another example also. Suppose this is my point. Okay, and I take this is my line. Okay, my line is moving from inside to outside. This is my line. So what is my first edge? Yes, it is having the direction. What I'm going to do, add 1. Here it is another edge. These two are both different directions. See, this is moving in this direction, this is moving in this direction. So this is 1 is added, 1 is subtracted. The answer I will get it as 0. If the answer is 0, what is the output or what it indicates? The point is exterior point. It is considered as a exterior point. No issue with this. Now we take this as an example. Okay, I consider this is my line. Okay, and for this line I'm just going to do this. Okay, I'm just going to do this particular thing. Okay, now what is my first edge? It is crossing. My first edge is crossing in which direction? It is moving in this direction. Please look at this very carefully. This is my first intersection, it is crossing, and what is my direction? It is direction is this. Second edge it is crossing. What is the direction? I think my directions are same. Both edges it is crossing, directions are same. So here also 1 is added, here is also 1 is added. My number is non-zero, it is 2. Winding number is 2. So this region is consider as interior. This region is interior. Okay, all of you get it? This is the interior region. Okay, suppose I take another way. This is my point, and suppose I take the line from this to this. Okay, line from this to this. This is my first intersection. First intersection, what is the arrow? It is moving in this direction. One is added. This is my second. Again, it is having the same direction. See, my edge crossing for both the edges, two edges, but both are having the same direction. So one and one is added. So answer is 2, which is non-zero. Okay, if it is non-zero, the piece inside. That's why I'm having this position. This area is inside the polygon. Okay, that's why I'm having this test. Okay, I hope so all of you clear. If I take this as an example, okay, I take this as an example. This is my internal point. I'm moving from this point to outside. It is crossing one edge. Yes, this is the arrow, one edge, and I'm having add one. Okay, one is added, so my answer is 1. Answer is 1 means it is non-zero, so this is inside. Getting me? If you want to take another example also from the exterior point, suppose this is my point. Getting me? And now I'm having moving in this direction. Okay, so you just move in any direction. Okay, what is my first edge crossing? My edge which is crossing, okay, that I'm considered here is, okay, this is my first edge, it is crossing, and another edge it is crossing. So I can found that the, see what I'm having here, I'm moving from this point to this point. I want everyone to take it carefully. This is my first edge. First edge direction is like this. Okay, and what is my second edge? Second edge direction is opposite of this. So this is one is added, but one is subtracted. So answer is 0. Answer is 0 means this is exterior. This is outside. Okay, so this is what the way I am applying non-zero winding number rule is applied. Non-zero winding number rule is applied, and this is what we are applying for inside outside test. Okay, I hope so all of you understood these two methods. One is odd even rule, and second is non-zero winding number rule. The non-zero winding number rule, step number 1, we have to show the direction or the flow of the polygon in anti-clockwise direction, and then accordingly we will just find the winding number. Okay, I want that count of the winding number if it is non-zero, because we are adding 1, and second we are adding subtract 1 if the directions are different. Okay, means from moving from right to left or left to right accordingly. And if it is non-zero, then it is interior, and it is 0 if the answer is 0, winding number answer is 0, then it is exterior point or inside outside the point. Okay, so this is what we have learned today, inside outside test. But I'm having just one more discussion for you for last slide of the today's session we are considering in short. Okay, now here the last point that we are discussing is as shown in the diagram. Okay, interior exterior regions defined by the non-zero winding number rule for self-intersecting set of edges. Okay, as shown in the diagram, we are having interior and exterior region. Just now we have seen the diagram for this. Now what we can say now is we have learned two methods. Okay, now what is our conclusion? For standard polygons or standard regions, both the methods, odd even rule and non-zero winding rule, both the method gives the same result. Okay, the output of odd even rule as well as non-zero winding rule, both are same. Answer is, or the result is same for standard polygons. Okay, standard polygons means the polygons which are not intersecting, self-intersecting, or which are not complex. Okay, but for more complicated shapes, which is self-intersecting polygons, for more complicated set, the two methods gives the different result, may yield the different result. Okay, interior and exterior regions might be different as the case as shown here. Okay, so these two methods that we are having, okay, may gives me the different result. If I use odd and even rule, the answer may be different. The non-zero winding rule, the answer may be different. Okay, for which polygon? Which self-intersecting polygon or complicated shapes polygon. Okay, whereas for standard polygons, both the odd even and non-zero gives me the same result. Okay, this is my conclusion. Now how I say it is different, I think just now we have seen this both the cases. Okay, we have seen this particular diagram, this as an example. You can find that in the A diagram where I have applied odd even rule, in diagram A I have applied odd even rule, and I have found that this particular region is exterior. In odd even rule, this region is exterior. Getting me? Whereas, but in non-zero winding number rule, in non-zero winding number rule, the same region, this is the same region. Okay, what is my result? But it had shown that it is interior. Okay, so in odd even rule, the region is exterior, but in the non-zero winding number rule, the same region is there, but now it is considering that this region is interior. Means for non-zero, this region is inside, but for odd even rule, it is outside. Okay, so that is what I have said for the self-intersecting polygons. So what I have said, for the self-intersecting polygons, the or complicated shapes or complicated polygons, these two methods may give me the different result. Okay, interior and exterior regions might be different as shown below. Okay, we have just considered this as a case. Okay, so this is what there, but let it be. I think it is on our as per the application, we are going to apply the odd even rule, or we are going to apply the non-zero winding rule. Okay, so but if it is a standard polygon, okay, not self-intersecting polygon or not complicated shapes, then always this both the method gives me the same result of inside outside test. Okay, our aim of the session that we have discussed today is to find out whether the region, whether the point is inside or whether it is the outside the polygon. Okay, so that if it is inside, obviously we know that if the region is inside, we are going to fill it with the color. I think here the polygon is filled with the color as a blue. Okay, faint blue color. Okay, you can find this is it is filled, and if it is found that the region is exterior, means the region is outside the polygon, then it is set with the background color, or it is not filled with the color. Okay, now to whether to fill the color or whether to not fill the color, I think we are using this inside outside test. And under the inside outside test, we have learned there are the two methods. One is known as odd even rule, and the another is known as non-zero winding rule. Okay, non-zero winding rule and odd even rule. Okay, I hope so. Or if you have, with the help of these two diagrams, diagram A and B, you have learned the methods in detail. Okay, how it works. Okay, so we end our session here. Okay, so thank you all the students. Thank you.